So we're going to look at how you can graph a line just by glancing at it. This is important enough, Brody, that I'm going to press pause for a day, and we're just going to practice a lot of this. What we're going to talk about is the what we call Slope-Intercept Form. Now there's your lesson, but I just want you to look up. Here's a graphing calculator I found online, a free one. And I'm going to make up an equation, but I'm going to make up an equation gradient with the y by itself. I'm going to graph y equals 2/3 x plus 1. Okay? There's the graph. Let me zoom in just a tiny bit. I want you to notice or take a look at this graph. Now you can barely see the lines. Hang on. New blank graph. No. Print this graph. Share this graph. Options. Projector mode. Haha. Nice. Thank you. I like that. Now you can see the lines a little better. If I go from right here to right here, what's the slope? What? 2/3? Can you see a 2/3 anywhere in the original equation? Where?
2/3 x.
The number, the coefficient of the x? And if I look at the y-axis, what's the y-intercept? Right there.
1.
Positive or negative?
Positive.
Can you see a positive 1 anywhere in the equation? I wonder if that pattern continues. Let's try another one. Let's go y equals, how about negative 2x plus 4? Let's see what that one looks like. Oh, didn't want to zoom in too much. Zoom out one. What's the y-intercept? 4. What's the slope? Negative or positive?
Negative.
Negative what?
2.
Down 2/1. Hey, if this shortcut works, this is a pretty good shortcut. So what would happen if instead of a positive 4, I put a positive 2 right there? Now the y-intercept is too high, same slope. See it, Brianna? What if I got rid of the negative? Positive 2/1 slope, y-intercept of 2. What if I put a minus there? What's the y-intercept now, do you think?
-2.
Let's see. Oh yeah, negative 2 is the y-intercept. What if I put a 2/5 there? What should the slope be?
2/5.
Let's see. Still a y-intercept of negative 2, and then it goes up 2/5. Hey, it does have a slope of 2/5. This is why we practiced, Amy, getting the y by itself. This is what we call slope-intercept form. Slope-intercept form says, look, if you take an equation and you know it's a line, Ashley, no curves, and you get the y by itself, the x coefficient is your slope. The constant term is your y-intercept. In fact, it looks something like this. So far, from last lesson, we've learned that lines are created by equations like y equals 3x minus 1 when y is by itself, or like 2x plus 4y minus 7 equals 0 when y is not by itself. I'm just making them up. But here's what we do know. The x can't be a power, x cubed, x to the fourth. Those gave us curves, right, Brianna? Inside a root, square root, cube root, which actually, according to flower power, is technically a power anyway, so it's really the first rule again. or have an exponent, or anything else, any weird stuff. The equation creates curves. If the y is not by itself, we can manipulate the equation to get it there. I wrote down, try these, solve for y, but you guys said you had no questions from the homework, so I'm going to skip them, and I'm going to go straight to this. This is the important point of this whole lesson, in fact, of this whole unit. When the y is by itself, we say that the equation is in, underline this, slope-intercept form. And we give it the general form y equals mx plus b. Which you need to memorize. Oh, what did the letter lowercase m stand for already? We talked about that. Slope. And what variable do we use for the y-intercept? B. Why B, Mr. Because not all math was done by English-speaking people. And to be honest, that one, I don't know where the letter B came from. I know the letter M came from a French or German word for mountain, for steepness, but I don't know where the letter B came from. But it's been that way for a couple hundred years. Y equals mx plus b. Y equals mx plus b. Anthony, the number in front of the x tells you the slope. The constant term tells you the y-intercept. Oh, what if there is no constant term? Then your y-intercept is 0. To show this, I wrote, graph the line below and then find the x and y-intercepts using m equals y2 minus y1 over x2 minus x1. And find the slope. Okay. If I wanted to find the x-intercept, that means let y equal 0. I would solve this. Yes, Curtis? Right? I would, I think, plus the 3x to the other side. It's the same equation. You could minus 9 from both sides, but hopefully you picked up, Marcus, if I can get rid of a negative x, I will. 3 times what is 9? The x-intercept is 1, 2, 3. What about the y-intercept? Well, to do the y-intercept, I let the x be 0. I'll get this. Y equals negative 3 times 0 plus 9. What is negative 3 times 0? I really get y equals plus 9. Y equals 9. The y-intercept is at 9. The x-intercept is at 3. What's the slope? Well, if I go rise over run, so there's the line. If I go rise over run, first of all, negative or positive slope? I think the rise is 9, the run is 3. Yeah, Naomi? Which reduces to what? You with me now? Yes? We're good? Here was my whole point with that exercise. It turns out the slope is negative 3, which you already noticed, Alex, is the number in front of the x, but we've just proved why that's the case. The number in front of the x is the slope, and the slope is negative 3. The number after the x, the constant term, is positive 9, and that's the y-intercept. That's b. What does that mean? You don't need to graph an equation to find its slope and its y-intercept. All you need to do is rewrite the equation in slope-intercept form. And what that really means is Get what by itself? Because I asked you to. Yeah, get the y by itself. So you ready? Turn the page. Example 1 says, find the slope and the y-intercept without graphing. You know what? Since you all turned the page, I think at the top of the page we should write y equals mx plus b. This is our little template that helps us remember, Alex, what's what. M, sitting in front of the x, is the slope. Positive b is going to be the y-intercept. What's the slope of graph A? Or 5 over 1. What's the y-intercept of graph A? -2. You know what this graph would look like? It has a y-intercept of -2, 1, 2, and it has a slope of 5 over 1. It would be a very steep graph that goes through the y-axis 2 down. If I had graph paper, I could sketch it. Hurry. B. Is this one in slope-intercept form? Okay, we're going to have to get the y by itself first. How? Since this was your homework, how? Yeah.
Subtract 2y with
And I'll get 6x minus 10 equals -2y. Haven't quite got the y by itself. Now what? Everything by -2. Divide not the two numbers, all three terms, everything. Divide by -2, divide by -2, divide by -2. Here they cancel. Woohoo! And I end up with y equals, what is 6 divided by -2? Does that work out evenly? Now, if it doesn't work out evenly, just leave it as a fraction in lowest terms. But this one does. -3x. And what is -10 divided by -2?
5.
I heard 7. I heard 5. 5, positive or negative? Because that reminds me to put a plus. Positive 5. What's the slope of this graph? Am I going to write the over 1? What's the y-intercept of this graph? 5. C. Try finding the slope and the y-intercept on your own. Get the y by itself. I'll do it up here if you get stuck. I caught it. My brain was already working ahead. Is that right? Yeah? Brody, okay? Yeah? I get a slope of 5 over 2, which means I would count up 5 over 2. I get a y-intercept of -9. This is how you graph. Brady, this is how you graph. Do the y-intercept first. 9 down. And then from there, what's the slope? Up 5 over 2. Up 5 over 2. Up 5 over 2. Dot. Up 5 over 2. Dot. Up 5 over 2. Dot. That's how we graph. We don't actually do tables of values unless we absolutely have to. So, now that we know the y-intercept and the slope, it says we can sketch the graphs without graphing. For example 1, sketch the equations on the grid provided below. Label each line. So, what was the slope and the y? Always graph the y-intercept first. For line A, the y-intercept was positive 2. What was the slope for line A? Sorry? I heard it. 5. This is when I do want it as a fraction. So I won't write it as a fraction, but 5 over what, technically? Oh, negative 2. I'm sorry. Sheesh, Mr. Duick. Candy for you. How about a y-intercept of negative 2? Good gosh. Who caught that one? Tyler gets the candy? Okay. Back to that, Tyler. What's the slope? 5 over 1. That means count up 5 over 1. Up 1, 2, 3, 4, 5 over 1. That's a point on this graph. Up 1, 2, 3, 4, 5 over 1. That's a point on this graph. I can even back count. Down 5, back 1. 1, 2, 3, 4, 5, back 1. That's a point on this graph. And in fact, now I can use a straight edge or a ruler, and I can connect them. That's line A. Line B. We said that one had a slope of negative 3 and a y-intercept of positive 5. So I'm going to start out with my y-intercept of positive 5. Ty, did I get that one right? I did? Whew. What's the slope, Ty? Stop. That means down. Negative what? Over. So down 3 over 1. Always over to the right, but the negative tells you whether to go up or down. Down 3 over 1. 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 And I can go back 1 up 3. And I get I'll call that line B. Line C. That one was, 5 over 2x minus 9. What's the y-intercept of line C? So I'm going to put a dot at negative 9. Doink. And what was the slope? Positive or negative? Positive. Up what over what? Up 5. 1, 2, 3, 4, 5 over 2. Up 5. 1, 2, 3, 4, 5 over 2. Up 5. 1, 2, 3, 4, 5 over 2. There is line C. Mr. Duick, why did you put arrows on the ends of each line? Because I think they keep going. There's more points. I want to show that. They have a domain of all reals and a range of all reals. That is graphing slope-intercept form. We need to talk about two special cases. The first case is if there's no x term. If you have, for example, y equals 3. I'm going to argue, Darian, that this is the same as y equals 0x plus 3. Because what would 0 times x be? And would I bother writing it? But I'm telling you that's where it came from. What's the y-intercept? Can you see it? 3. What's the slope? What's the number in front of the x? 0. What does a slope of 0 look like? Ah! Did you hear him? Did you hear him? The line y equals 3 is a horizontal line. How high? 3 high. It has a y-intercept of 3 and a slope of 0. Does that make sense? Ties into actually what we've already done. It would look like this. What would y equals negative 1 look like? A horizontal line. How high? What would y equals negative 1 look like? It'd be a horizontal line. How high? Negative 1 high. Now, this bugs people because Amy, since they see a letter y, they really want a y equals 3 to be vertical because the y-axis is vertical. And so they say, well, the y-axis is vertical, then why isn't y equals 3 vertical? But hopefully I've just convinced you what that really means is you have no x, and the only way you can have no x is if the number in front of the x was what? 0, which means you had a slope of? Same answer. 0, and that's a horizontal line. The other possibility is you have no y term, like x equals negative 2. Let's see if we can take a guess. If y equals 3 gave us a horizontal line, 3 high, what do you think x equals negative 2 is going to give us? What kind of a line? Vertical line, 2 left, because it's negative 2. It's going to look like this. And again, Tyler, kids get this mixed up, unfortunately, because they say, oh, it says x equals. Shouldn't an x equals be like the x-axis, horizontal? No, a y equals is like the x-axis, horizontal. And x equals is like the y-axis, vertical. Oh, by the way, that red line, does it pass the vertical line test? Is it a function? I can graph it by hand, but I'll tell you right now, my graphing calculator cannot graph that little vertical red line. It'll crash every time. Something you can do very easily that a computer just doesn't. You have to write special code, special software, and they didn't when I bought this. Next page. So y equals a number produces horizontal line C high or C low if it's negative. X equals something, no y, that produces a vertical line C to the right or C to the left. Last thing we can talk about, finally, is the domain and the range of lines. Here's the line right here I'm giving you, my body. What's the domain? All reals. What's the range? All reals. What's the domain? What's the range? Which is the only ones that are weird? This one and this one. Here's the y equals 3 that we just did. What's the domain? All reals. Ah! What's the range? What's the only height that appears?
0.
Well, 0 if it's flat. 3 in the example that I gave you. So in the above example, for y equals 3, the domain is still all reals, but the range, just 3. Did this pass the vertical line test? Was this a function? Marcus is nodding. He is nodding correctly. What about the other one, which was x equals negative 2? Is that right? Okay. So here it is. What's my range? All reals. So y funky ER. What's my domain? What's the only x value that appears on this vertical line? Function, except, okay, that's a specific example. let's generalize this. So the way they generalized this, they didn't actually on this page use y equals 3. Instead, they said y equals what? C. What's the range? If y equals 3 gave you a range of 3, what would y equals capital C give you as a range? Ah, so you know what? Let's go like this, folks. Cross out the 3, put a C there, cross out the 3. It's if you have y equals some number, your range is some number. That number. Oh, and the same thing for the x's except for domain. So they actually said x equals C. You know what? The domain is going to be whatever that number, that their number is, that's your domain. Example 2 says, graph the following on the grid. Okay. I think I can fit almost all of this in. Line A. Is that in slope-intercept form already?
Yes.
Oh, excellent. What's the Y-intercept? Let's all put a big dot at -2. I'm going to make a little note here. I'm going to do this in blue. What's the slope? Also -2. That means, Brody, count. Folks, count how? Down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. And I can go backwards in the opposite direction. I know it's linear because there's no funky exponents or anything. I'll get out a straight edge, my ruler. I'll say that there is line A. Line B, I'll do this one in black. Is it in slope-intercept form? It is, Curtis? Excellent. Curtis, my friend, what's the Y-intercept? I agree. I'm going to put a big dot right there. What's the slope? What's the slope, folks? Where'd that come from? X coefficient. Okay, Curtis? What's the slope? The number in front of the x. What's the slope? Which means count how?
Up 3 over 1.
Do you see the problem? If I go up 3, I'm off the page. But I definitely know there's going to be a point right there, and I can back count. Down 3, back 1. 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 It's going to look like that. That's line B. Hey, what do you notice about those two lines? They cross. See it? Where do they cross? What, comma, what?
-2,
Okay. Next unit, Jordan, we're going to ask ourselves, how can I find where two lines cross without graphing them? And that turns out to actually be very useful. It's called a system of equations. It lets you solve two equations at once for two different variables at the same time. It's a nice time saver. It builds on the equation solving that we've already done. We'll say, hey, where do they cross? Where's the intersection point? Solve the system. The first way you'll learn, Jordan, is to graph them. And then I'll say, oh, who wants to get out graph paper all the time? There is a way to do this algebraically. Line C. What's wrong with line C? It's not in slope-intercept form. Okay. You know what? I got room. Is that the same line? I wrote down 2x plus 4 equals 4y. Is that the same as line C? Is it a line?
No.
It's not? How's it different? Can you read line C to me, kiddo?
2x minus 4y plus 4 equals
What could I do with that minus 4y?
Absolutely.
Is that what I did here?
Yeah.
So I'm going to ask you again, is it the same as line C? It is. Does it look different? Yes. But is it actually the same equation? Yep. I did one step, the first step in my head. If you do that, I'm okay with it. What am I trying to get by itself for slope-intercept form? Because I asked you to. Come on. Oh, okay. How will I get the y by itself, Anthony?
Divide 4.
Everything by 4. Divide by 4, divide by 4, divide by 4. And I'm going to get this. Y equals 2 over 4. What's 2 over 4? A half x. And then there's a plus sign, so I'll put a plus sign. 4 over 4.
1.
What's the y-intercept here, Anthony?
1.
Let's do this one in red. Y-intercept is positive 1. What's the slope?
1 and 2.
So that means count how?
Up 1 over 2.
Like this, you're saying? And I can back count. Get out my trusty ruler. That there is line C. Hey, let's keep going. Try D on your own. Is D in slope-intercept form? No, no. I'll do it up here. You can do it on your own. Let's see if we get the same thing. I'll do D in blue. Is that right? Ah. I got y equals negative 1x, or you could just write negative x, and I would clue in there was a 1 there, but some of you hate that, so I put the 1 there. What's the y-intercept here?
0.
0, because it's invisible. What's the slope?
Negative 1.
Which means count how?
Down 1. Up 1.
Down 1, right 1. Always to the right. The negative tells us up or down, but we always got to go to the right. Otherwise, you'll accidentally do a double negative and cancel out what you didn't mean to. So this one has a y-intercept of 0. And it's down 1 over 1, down 1 over 1, down. In fact, this is a 45-degree angle line right down the middle of the graph, splitting it in half. Oh, it also crosses this line here. Cool. All right, Mr. Duick, let's see if you can try this. Go down. Yeah, that'll work. Click. You're going to go there. And come on. Oh, I like that. There we go. Couple more, we're done. E. Ah! What's weird about E? Okay, you're missing a letter. So this is either horizontal or vertical. It's either horizontal 7 down or it's vertical 7 left. Which one? Sam?
Vertical 7 left.
Okay, so that's going to go... I'll do this one in the... Actually, I'm going to do this one in... Well, I'll do it in black. It's going to go like this. Really thick, Mr. Duick. That is line E. F. Ah! What's missing in F? Okay, so it's either a vertical or a horizontal line. It's either a line too high or it's a line too right. Which one? Horizontal line too high. It's going to look like this. G. Is that line in slope-intercept form? Okay, let's get the y by itself. So let's write G down right here. My original equation is 3x plus 2y equals 5. Now what? Sorry? Minus 3x. So you're saying this is going to be 2y equals minus 3x and a plus 5? Is that okay doing that in my head? Are you okay with that? Yeah? Now what? Now what? Divide by 2, divide by 2, divide by 2. And I run into a problem because I get this. Y equals negative 3 over 2x. That's not a problem. I can do a fractional slope. In fact, Jordan, a fractional slope makes things easier. But I get this as a y-intercept. What the heck is 5 over 2 as a y-intercept? Well, you could argue, Amy, it's 2.5. But when you try eyeballing 2.5 on this graph, I would argue that you're just kind of doing a best guess. If you say, well, Mr. Duick, I kind of sort of think it's right about sort of kind of here, how do you know you're not a millimeter off? So, Amber, we're going to run into a problem. We're going to need something else. Our slope-intercept form does not work well when our intercepts are decimals. Oh, and in science, that happens fairly often. That's a preview of coming attractions. We need another method to deal with decimal intercepts. That's lesson 6. We're going to learn something called point slope form or slope point form. Nearly done. Turn the page. You know, one of the reasons slope-intercept form is so nice is not only can I give you the equation and say, hey, show me the graph. I think I can go, hey, here's the graph. Show me the equation. So this says, give the equation for the following lines. Here we go. What's the equation for line A? Well, did we all just turn the page? Did you guys? You know what? At the top, write y equals mx plus b, because that's our template. That's our pattern. That's what we're filling in. So take a look at line A. What can you fill in already? Which of these numbers can you get right from the graph? Plus 5? And there's going to be an x right here. And what else can you get? I think the slope. What's the slope? Negative 2 over 3. Down 2 over 3. Right? From here to here. Cool. B. Y equals what? What's negative 3? Oh, so leave a space, and you're saying put a minus 3 there? Yep. What's the slope?
2 over 5.
Up to over, you know what, I think it is. It looks like it's up to over 5. Yeah? By the way, a lot of kids do this, which is wrong. What have we forgotten? The X. That's one of the most common mistakes I'll see on a test. Kids are so proud. I got the Y-intercept in this slope. Look at me. You got to fit it into the form y equals mx plus b. C. Is this going to be y equals mx plus b?
No.
What's this equation then? X equals negative 4. D. Is this going to be y equals mx plus b? No. What's the equation then? Y equals 3. E. What's the problem with E? Yeah, and you have no way of telling how high that is. Curtis, you might say 1.8. I might say maybe it's 1.79. Maybe it's 1.793. I don't know. We need another method. We need another method. But if the intercept is not a decimal, Brady, it's kind of paint by numbers, plug and chug, fill in the blanks. Slope-intercept form. Very nice. What's your homework? Number 1. Number 2. Three is good. 4, I'm going to say A and B. All right, you need to practice slope-intercept form. So 5 all. You're going to find, hopefully, I hope, after a few of these, Amber, you can kind of start doing some of the steps in your head. I'm good with that. On a test or a quiz, probably not. In your homework? Sure. And then we need to graph. So 6 is good. You know what? 6A. I'm not going to make you do domain. Sure, let's do all of number 6. That's good practice because you can get it right from the graph. You can find the X-intercept and the Y-intercept and all that stuff. So far, have I signed everything? I skipped one. No, I've signed everything so far? Oh, I skipped C and D from number 4. Oh, and apparently I skipped number 7. You know how I know I skipped number 7? I don't see number 7. And we'll pause there. Did I assign number 8? Well,